Let's see how we can modernize the builder pattern in Kotlin. Today, we'll explore why the builder pattern might be helpful, then we'll implement it using a traditional implementation from the classic Gang of Four design patterns book, and finally, we'll see how we can use Kotlin's language features and library features to improve upon it. So let's jump in. Here I've got a simple class representing notification settings where you can subscribe to some topics like the latest news updates, the analytics for your account, and security updates for any suspicious activity. You can subscribe to any of these topics with different frequencies. So for example, you might want a roll-up of your analytics each day. You might only want the news once a week, but you might want those security alerts right away. And the destination types here determine where the notification will go, so either to an email address or to a phone number. And you can see I'm calling the notification settings constructor directly right here, and some other constructors for subscription, email address, and phone number down here. Now, one of the issues with calling the constructors directly is that we have to build out the entire settings in a single shot. And so traditionally, with more traditional programming languages, for example, we can't split up the construction of an object into multiple statements. And we'll see workarounds for this in Kotlin in just a minute. But for now, let me show you what I mean. So if we want the caller to pass in the email and phone number, but we only want to subscribe when they're not null, well, we can't just add conditionals to the list of subscriptions here. This won't compile because Kotlin's expecting an argument for the list of function here, so we can't use an if statement to tell it to only include the subscription under certain conditions. And similarly, if we wanted to use a loop to add some subscriptions, or if we need to reference other parts of the notification settings while the object is still being built, we don't really have a great way to do that. Well, the builder pattern is designed to split up the construction of an object into smaller steps. That'll allow us to use multiple statements when creating our object. So next, let's take a look at a traditional builder pattern as described by the classic Gang of Four book. So here I've introduced a new class called Notification Settings Builder. And you'll notice that this new class has some very similar properties as the original notification settings class up here. But instead of making them constructor properties, I've made them regular properties, and I also made them mutable. So we've got a mutable property for enabled and gave it a default of false. And then the list of subscriptions isn't a mutable property itself, but it references a mutable list so that you can add and remove elements from it. And I've also made that property private so that you can only add to that list through the add subscription function. And in some ways, this looks a lot like the notification settings class that it's going to instantiate, but it's got an empty constructor, or what you might call a default constructor, and its properties can be changed. So for what it's worth, I've also included an interface for this builder class down here. And in our case, it doesn't really add much, but since it's traditionally part of this pattern, I included it just to be thorough. And with this setup, we can still specify how the object should be constructed, but we can use multiple statements to do that. And then once we're done specifying how it should be constructed, we can call the build function like we're doing down here to get our final notification settings object. Now, because we can split up the construction across multiple statements now, we're able to use constructs that we couldn't use before. So for example, we're now able to use conditional statements to add subscription only when an email or phone value is present. And we could also easily add a loop, such as if we wanted to subscribe to every topic. And we also get some flexibility in the order that we specify the properties. So for example, we can set enabled to true up here, or we can move it down below the subscriptions if we want. So the builder pattern is designed to give us some flexibility when constructing a complex object, mainly by allowing us to split up construction across multiple statements. As with the factory patterns that we looked at last time, the object being created is known as the product. The interface providing the operations that you can perform when building the object is called the builder. And then the class that actually builds it is the concrete builder. And then the code that tells the builder what to do is known as the director. And in the design patterns book, this was a class, but in Kotlin, we can just make it a top-level function like I did here. Okay, so how can we use Kotlin's language and library features to modernize the builder pattern? Well, to start with, we should ask ourselves what it is that we're trying to achieve. So if all we care about is the ability to provide a default value or the ability to specify properties in a different order, we don't need a separate builder class at all. In fact, we can just use default arguments. And as long as we're specifying the parameter names when we call the constructor, we can shuffle around those arguments at the call site. But as we saw, there's also a lot of flexibility that the builder pattern gives us because we can construct the object across multiple statements. So how can Kotlin help us with this? Well, you've probably used Kotlin's scope functions at one time or another. Functions like let, apply, run, and also. And one of the key characteristics of scope functions is that they allow you to wedge one or more statements into a part of the code that expects an expression. So in other words, we can use the run scope function here, and that will let us build out this argument using multiple statements. So we can create an assignment statement to introduce a mutable list, and we can add to that list, and then we can return it from the end of that lambda. And this also means that we can do things like use conditional statements. We could also use loops and other kinds of statements as well. Now we can use a scope function to build out an argument inline regardless of that parameter's type. But since we're specifically building out a list here, Kotlin will help us out even further. So instead of using a scope function, Kotlin's standard library provides some functions exactly for the purpose of building out collections. So we can just change run to a function called build list, and then we no longer need our own mutable list. We can just call add directly inside this block of code, and the block of code will evaluate to the constructed list. A while back, I made a video that covers collection builders in more detail, including some of the additional benefits of using them. So I'll link to that one in the description just in case you'd like to explore collection builders further. So with default arguments, named arguments, scope functions, and collection builders, there are a lot of cases where we just simply don't need a builder pattern at all. But still, there are some occasions when the object you're constructing is just complex enough that a builder pattern would be a good fit. And in those cases, we can take things even further using a feature called lambdas with receivers to make our builder classes even easier to use. So here's the builder code that we saw earlier in this video, except that I removed the interface because I didn't really think it was that necessary. At its simplest, we can just add a function to wrap the construction of the builder. So to do this, I'll just create a new function called notification settings, and it'll accept a lambda with a receiver. So I specify the type to the left of the parentheses with a dot, and this function just instantiates the builder, applies the lambda to it, and then returns the built object. And then to use that function, we'll just call it with a block of code, and inside that block of code, the receiver is the builder object. So we no longer need to specify builder dot everywhere. And if we want it to read like more natural English, we can even get more creative with it. So for example, we can replace our existing add subscription function with a function named send, and this function takes a pair of topic to destination. And by doing this, the call site will actually read somewhat more naturally as send analytics to email daily, or send news to email weekly, or send security alerts to phone immediately. And builder DSLs like this are fun, and it's really easy to go overboard with clever syntax, but when used judiciously, I think they can make complex object construction a lot more expressive. So there we go. In some cases, Kotlin can completely obviate the need for the builder pattern, and in other cases, it can make those builders even more expressive. Now, if you were looking closely at the code in this video, you might have noticed that my build function was converting a mutable list to an immutable list. So not just casting it to a general list type, but converting it to an explicitly immutable list. Well, the next episode of the Type Alias Show livestream is coming up in just a few weeks, and for part of that episode, we're going to take a look at Kotlin's immutable collections library and some of the cool concepts that are behind it. We'll also look at some of the latest things happening in the Kotlin and Android worlds. I'll answer some of your questions and a whole lot more. Plus, you'll get to hang out in the chat with lots of other Kotlin enthusiasts like yourself. We're planning the next episode for Wednesday, October 30th at the usual time, so 10 a.m. US Central. And you can use the links in the description to add it to your calendar. Or you can join hundreds of other Kotlin developers who've signed up for my email newsletter, where you can get a heads up on all of the fun things that I'm working on. And you can do that at newsletter.typealias.com. Thanks so much for hanging out with me today, and I will see you next time at the live stream.